right, we are in example D. You're supposed to write the expression for each of the following in terms of the given function. So what that means, when you're finished, you should have secant of theta by itself. It should be by itself on one side of the equation. And the other side of the equation, you can have as many numbers as you want, but the only trig functions you can have is cotangent. So the first thing you want to do is look through your identities, see if there's any identities that have both secant and cotangent in them. In best case scenario, it only has secants and cotangents in them. There's not. So our next choice is just pick an identity in which it has secant in it, that has something related to cotangent in it, such as the Pythagorean identity secant squared of theta equals tangent squared of theta plus 1. I think that's your best first choice. Now, once again, you're finished when you have secant by itself on the left. Currently, it's not by itself. And on the right side, the only trig functions that you use have to be cotangent. You can't have any tangents in it. Do you follow what I'm asking? Any ideas on how we can get secant by itself? Because right now it's not. It's not by itself because of the squared. Square root both sides. If you square root both sides, you're going to get secant of theta equals plus or minus radical tangent squared of theta plus 1. The left side now is perfect. Secant's by itself. Right side, not so perfect, because we have a tangent in it. It's supposed to be cotangent. So now your focus is, how do we get tangent to be cotangent? Concussion. You have a question, sir.
Yeah, when we square root the tangent squared, why wouldn't that cancel each other out?
All right, boys and girls at home, here's the question. Why does this not equal this? Those are not equal. Let me give you an example with numbers to prove it, because with stuff like this, it's hard to comprehend. Let's say that we had a 5 squared plus a 4 squared. Using the above rule, it doesn't work. That would give you 5 plus 4, which is 9. Agreed? If you followed order of operations and you took 5 squared, which is 25, 4 squared, which is 16, that would give you 41. Square root of 41 is not 9. So the point is, when you do radicals, if there's pluses or minuses in it, you can't just take the square root. So any ideas on how we can change tangent to be cotangent? Yes, sir. That's great. Now, as simple as that is, what he said, we're not finished, which is unfortunate, and I'll explain why. He said use the reciprocal identity for tangent. Tangent reciprocal is cotangent. So you can change this to 1 over cotangent squared of theta. That's a reciprocal identity. Replaced tangent squared of theta with 1 over cotangent squared of theta. Here's why we're not finished. We've done what the directions asked, but algebraically, you're not supposed to have radicals on the bottom of a fraction. Since we have a fraction, that means there's a radical on the top and bottom. We have a lot more work to do. It has nothing to do with trigonometry. We need to first add these two fractions together, the 1 and the 1 over cotangent squared of theta. To do that, you need common denominators. The left side's not going to change, so I'm not going to keep writing it down. You can write it down if you want, but you don't need to. So I'm going to change the 1 to cotangent squared of theta over cotangent squared of theta. Anything divided by itself is 1. So we have not changed the value, we just changed the way that it looks. Once you have common denominators, you are to add the numerators, leave the denominators the same. The numerators are not like terms. Once you have it as one fraction, which we do now, then you can square root the numerator and square root the denominator. Please note the numerator is not a perfect square because of that plus that's in there. The denominator is a perfect square. The denominator's square root is just cotangent. So our final answer, secant of theta equals plus or minus. This plus or minus can go in the numerator or the denominator or out in front. It doesn't matter where you put it. I'm going to put it in the numerator. 1 plus cotangent squared of theta divided by cotangent squared, not squared, just cotangent of theta. So there's basically 3 requirements. It says in terms of the given function, so it's in terms of secant. Well, I said that wrong. Yeah. Secant's by itself. It's in terms of cotangent. And then the third thing is make sure it's simplified. You can't have radicals in the bottom of your fraction. So that is finished product. Questions? These are probably going to be the most difficult problems that you're doing. And mostly because people forget what the directions are asking you to do. Number 2, cosecant of theta in terms of cosine of theta. This is the last problem in our notes. You have to have cosecant of theta by itself on one side. On the other side, you can have as many numbers and addition and subtractions as you want. But you can only have cosines.
If there's not one that don't put them together, how do you know whether you use the one that has the cosecant and the one that has cosine?
You don't, you just guess. Concussion.
Would we use the sine squared of... No.
Oh,
Use
yes.
this.
Finish.
Plus cosine squared of theta equals 1.
Yes, that's correct.
You're scaring me.
It's not the one I used on my paper, but it doesn't matter.
Oh, God.
Yes, my son. Here's why this is a good one. It may not seem like it's a good one, but here's why it's a good one. Obviously, you can see that we have cosine in the problem, which is great. We don't have cosecant, but hopefully you recognize that cosecant and sine are related to each other. They're reciprocals. So with some work, we're going to be able to accomplish this. Suggestions? All right, let's get cosine by itself. That's what I'm hearing people saying. Let's get cosine by itself first. If you subtract sine from both sides, you get cosine squared of theta equals 1 minus sine squared of theta.
I thought it was the cosecant that was...
Yeah, that's true. That's probably not what I wanted to do. That's not what you... I don't think anyone actually said that. I think I just misinterpreted. Let's get sine by itself. How about that? Yeah, let's subtract cosine. How would you get sine by itself? So this is turning out to be pretty similar to the last problem.
They're all going to be similar?
If you do enough of them, there'll be enough that you've done that it's similar to a different problem that you've already done.
Good call.
Right, we have sine here. We have to change sine so it's in cosecant. How would we do such things?
Now you
Do
can
you
multiply.
change the reciprocal something? Yeah.
What does that mean? I don't know what that means.
It'll equal theta.
So we seems like we're pretty close, but we're not quite there yet. We do have cosecants and cosines only, which is great. But one side has to be cosecant of theta, and just that. It can't be the bottom of the fraction, it has to be the top. Awkward. What if we were to multiply both sides by cosecant of theta? That would get it off the bottom of the fraction. That's what we're going to do. So we got 1 equals cosecant of theta times plus or minus the square root of 1 minus cosine squared of theta. Then you get cosecant of theta by itself, divide both sides by that square root. Then it'll be by itself.
Then we're just going to have another fraction.
You can have fractions. Cosecant can't be a fraction.
You can't have a radical on the bottom of a fraction.
No, you cannot, ma'am.
We're getting there.
Seems like there should be an easier way to do this.
Very true.
Yeah, the easiest way to do this is to sign up for financial math. It's the easiest way to do this problem. Can't have a radical on the bottom. Suggestions on how to fix that. Multiply what by the top and bottom? Yeah, multiply what's on the bottom by the top and the bottom. The top is going to be plus or minus the square root of 1 minus cosine squared of theta. The bottom, when you multiply something by itself, you're squaring it. The squaring and the square rooting cancel, so the bottom is just 1 minus cosine squared of theta. What I'm saying is the bottom did have a square root, and then if you square it, this squared and the square root cancel. Oh, no. Finished.